And welcome to my YouTube channel. Today is the 5th of February, year 2022, so I'm very much alive and well, surviving these, if I could say so, peculiar times. Definitely interesting seasons that we're going through. Anyways, your host remains unchanged, none other than David, or Dave is on the other side of the camera or the smartphone. I wanted to make a very special video on a dear laptop that I have, which has become broken. So what you see in front of you in a pretty much disassembled state is an ASUS K52E laptop. This one is very special because I got it as a sort of a counter payment or counter barter item for another set of services that I provided for an acquaintance that I met towards the end of 2018, beginning 2019, and that's also the time when I got this laptop. So the problem with this one in particular is maintaining stable power. Specifically, when I'm running the laptop only on the appropriate 90-watt AC adapter, I cannot turn it on. So that's really kind of not good. But if I pre-charge the removable battery via another set of equivalent ASUS K52 series laptops and run the laptop through the removable battery, the laptop works fine. And also when I press the power button, it turns on and goes through post and everything else. But when I want to, for example, charge the removable battery, I cannot charge it or run it via the AC power adapter. That is a no-go. So what is the point of this video? I'm going to show you what I discovered and also how to fix this. So stay tuned. Before I dive in straight away into the fix, a few words on how the video is going to be organized or structured. First, we're going to identify the problem. So I'm going to show you where exactly on this lovely motherboard the issue is originating from. I'm going to give you a couple of close-up shots and a demonstration how fine this issue is. Then I'm probably going to record the actual process of fixing this, adding a voiceover probably in the post-processing, explaining you why this laptop is so dear to me. And then in the end, we're going to have some conclusional thoughts. Okay, let's begin. So as I have explained in the introductional part of the video, the main issue is, of course, that I cannot run the laptop merely or purely on AC power. So without using the removable battery, if I run it only on the AC adapter, I cannot even turn it on. Nothing happens. But if I pre-charge the removable battery via other series of ASUS K52 type of laptops and run the laptop only on battery itself, it turns on. Normally everything runs. But if I also insert the adapter, so the male connector into the female side of the connector located on the motherboard, it won't charge. So I would be completely stuck on battery. So where is this fix, or specifically where is the problem located? You may have guessed it. It's just pure simple logic or deductive thinking. It is the female side or connector located on the motherboard right here. I have repositioned the motherboard and the camera zoomed in a little bit on this particular female socket. Thank God for good lighting in the room, or basically that today is a sunny day because I'm not located in my usual place of recording, which would be, you could say, my top floor. I'm located in the basement where I have my, you could say, my new office space quarters, where also another side of the room is dedicated for electronics, where I have my soldering irons and everything, where I'll also probably be showing you the fix for this particular issue. But this is, of course, not final up-close shot of the problem, or basically how very sneaky this issue was created. So let's try zooming in a bit more. Recording this part of the video onwards the next day, so the 6th of February, year still 2022. Yeah, so yesterday the sun really quickly disappeared, but it also reappeared again about 1 hour or 2 hours later when I was already in my room. So I thought I was going to finish the recording yesterday, but I'm going to have to continue this today and hopefully finish it today. Well, anyways, this is a bit more up close, zoomed in section on the female connector side on the PCB. I've basically put a magnifying eyepiece over the lens of the camera, and I've used some two-sided sticky tape to secure it into place so that I don't have to hold it there, because I want to have both hands free. So I hope that you can see on the brass center pin, basically, that goes into the PCB coming from the back side of the connector, that you can see on top sort of a black O-ring. So that would be basically over here at the top. Hope you can see that. I'll try zooming in a bit more. There. Now you can see it much more clearly. You can also see, I think those are some sort of hair or something Yeah, so you would think that is just some sort of paint, but let me tell you, this is a crack. Yeah, so the center pin, the brass piece actually broke right there. And because of that, I don't have connection coming from the AC adapter onto the female connector socket on the motherboard. And basically this is why I don't have power. So, but let me show you another trick. I've repositioned the camera a little bit. So the crack is actually just thin enough so I can slide a piece of paper in between it. Voila. Let me readjust the camera. There you go. You can see it goes straight through. So of course, what is the solution? I don't need to explain this, but basically you do have two approaches to this problem, to be quite honest. Easiest fix to this issue, so without involving the process of finding a new socket connector, of course ordering it and waiting 3 months in order for this item to arrive. We know how the shipping delays nowadays are, and then getting rid of the old one, removing it off the board, installing the new one. The easiest cost-wise fix for this issue would be if I was to use a removable, of course, but very fine pointy tip on my soldering iron, also using a bit more thinner solder. I could just simply solder the breakage by joining these two parts together, and that would pretty much be it. Of course, I would have to be very careful because here is some sort of another metallic piece. It's probably the ground pin. I would have to be very careful when I would be doing the soldering work that I wouldn't in the process create a sort of a permanent joint between the plus and the ground, of course. But I do have steady hands, so I could definitely pull this off. Nevertheless, despite what I said previously, I'm going to go with the second option of approaching this issue or getting rid of this problem. Here, I mean buying a new connector, also the female socket, going through the process or hassle, removing the old one off the board, installing a new one, flooding everything with solder where it needs to be so to have a firm connection. Because with this particular laptop or the motherboard as such, the first time that I got this laptop, it came with a Intel Core i3 CPU. Can't recall at the moment which one it was, but because I got the 90-watt adapter for a pretty good price, this opened the doors for me to install a better, pretty much the maximum CPU this motherboard supports, which is a i7-2670QM CPU. So that means that through this center pin, there's going to be a lot of current flowing, and I have no idea how hot this can get. And if you have a breakage and if you have soldered that free air that is between the center pin and the piece that goes into the housing, maybe the solder can melt away, and again you have no connection to your motherboard, or there is no connection between the AC adapter and the board. And that's why I decided to go with the option of just simply buying a new connector. I have already acquired the new reserve female socket connector for this particular motherboard, so I am ready to make the swap. The new connector looks exactly the same as the old one. A bit more up close, so you can nicely see the solid center brass pin. A little side-by-side comparison. Yeah, so it's pretty much the same. So now we can start with the fix. First thing that I'm probably going to do is I'm going to apply my solder, which has a much more lower melting point than the one that is on the motherboard or with which components are soldered onto the surface. I'm going to apply it to all the joints around the female socket connector on both sides, so top and underneath. And I'm going to do this because solder that is on the motherboard, in this one in particular, but also speaking generally, it's not always the same in terms of the ratio between at least lead and tin. Also other components are present. And even though supposedly we're using lead-free solder, that's still to some degree not the case. So when my solder, which has a lower melting point, will mix with the solder on the motherboard, I'll be able to easily extract it via sucky pump thingy or the copper braid. I'm going to be probably using just these two items in order to get the connector out from its seat around this part of the motherboard. Maybe I'll use some flux as well, but that's pretty much how my strategy for replacing this will be. So let's start. I'm fulfilling the promise that I set out in the introduction on basically giving you some glory or juicy details on the state of the laptop when I first got it. So here it is. I acquired it in pieces. So the top palm rest was completely separated from the bottom plastic enclosure part. Hence also the motherboard was moving around very freely. It was not secured in its place, and that was a bit disturbing. To make it worse, the heatsink that was secured onto the motherboard was fixated by only 2 Phillips screws. Through those 4 posts on the CPU, pressing it down. Later on, I also discovered a quite larger crack near the optical drive of the plastic, so the bottom part. I was able to salvage that by simply epoxy gluing the 2 pieces together and thus preventing the breakage becoming larger. The optical drive, which I also got with the laptop, was missing the front mask though, so that was a bit of a disappointment. However, the keyboard, which was also with the laptop, just needed some deep cleaning or dusting off. It was completely fine. All the keys were in its place. They were not broken or scratched. The ribbon cable was fine. I was really happy though that the LCD screen hasn't been tampered with or disassembled, taken apart. So the front bezel plastic was firmly secured onto the back plastic lid, and the screen was safely snug in between, and the latter was also completely fine. No scratches, no breakage, nothing. And also what I found really great was that I also received the original battery for it, and that was of course very good. Even though of course the 18650 batteries were deeply discharged, I was able to jump start them and then use the battery to turn on the laptop to basically see that it runs fine. It just needed BIOS updates, and that of course led me to buy the 90-watt adapter later on. However, of course, the laptop came with absolutely no screws, even though they were acquired later on. I probably don't need to specifically point out that I also needed to replace the depleted CR2032 3-volt lithium BIOS, CMOS or RTC battery, and after doing the incremental BIOS updates, I started looking for the HDD caddy with all of its 4 screws because I didn't get it with this laptop. So that's it. That's pretty much the story. So the new female socket or connector is firmly and securely in its respective place on the motherboard. I have applied solder on all 5 sections on the PCB, or 10 if we're also looking from the bottom. Everything looks very nice. I'll give you a couple of close-up shots as well. Now all that I have to do is just pretty much reassemble the laptop and hopefully everything will work. Just look at those nice solder joints. Everything is full as it should be. Very nicely secured onto the motherboard. Very nice. And again, from this view, everything is full. No cold joints, nothing. Okay, so let's reassemble everything. Laptop has been, as you can see, fully assembled. Every screw is in its place as it should be. All the other components, optical drive and the likes, except for the battery, which has been removed. So I have everything ready for testing to see whether the change of the female socket connector on the PCB, did that process go fine without problems, or did I, in the process of, let's say with electrostatic electricity, did I destroy something else on the motherboard and the laptop won't turn on. So I have my AC extension power cord ready. The AC adapter for this laptop has been connected. As you can see, it has the green LED lit, so we have power coming into this adapter. Then now all we need to do is connect the other side of the DC side of the adapter into the female socket of the laptop. So let's see if something happens. So it is plugged in. Let's see what happens if I press the power button. Will the laptop turn on or not? It turns on. It boots, goes through the post process, and hopefully Windows 10 will be loading. Perfect. So the success is mine. I managed to fix the issue. Wonderful. As you can also see here by this tiny green SMD LED being lit, this means we do have continuous power coming into the laptop. So this is as it should be, I have to say. Great. I was really twitching whether I'll be able to get the fix done right because, well, honestly, this is the first time as such that I have been doing something like this. And you always have to be a bit more careful when you're dealing with electronics, especially in regard to electricity. Okay, now to sort of wrap up the video tutorial as such. So what was the point of me making this video? Well, I wanted to show basically how through deductive logic, or basically process of elimination, how you can find the fault when you have this sort of issue like I had when I would plug in the DC side of the AC adapter into the laptop and try turning it on and nothing would happen. And I removed the battery and I did all the trickeries in order to determine what could be the fault. In the end, of course, I had to disassemble the laptop and I discovered that the center brass plus pin on the female side of the connector was broken. It had a very tiny breakage, so I could fit a piece of paper between the center pin and the other side that was going into the housing of the connector. So this is what the video was about, showing you how to diagnose and also fix if you have come across this sort of issue. Therefore, the end of another tech-based video tutorial or guide on this particular problem. I hope you found the video somewhat informational, that you learned something new, maybe that you also revisited something that happened to you in the past. Anyways, if you're a new viewer, please subscribe. If you're an existing subscriber, thanks for staying with me so long. Don't forget to like the video and also share it. If you have any questions, suggestions, constructive criticism, leave that all down below in the comment section, which is open, and you're always invited to a civil discussion. Today has been the 6th of February, year 2022. I hope you all stay fine, healthy, and we'll see you in another tech-based video. This has been David or Dave. Bye. Toodles.